¿ok? En español sería caída libre, ¿verdad? Ese podría ser el nombre que podíamos dar, ¿ok? So what is free fall? When we talk about free fall, we are talking about the motion of a body when only the force due to gravity is acting on the body, okay? So basically, when we're talking about free fall, we're talking about something falling and the only force that is going to act on the body is the gravity, okay? So no other force is acting on the body, okay? The acceleration of an object in free fall is called the acceleration due to the gravity or free fall acceleration, okay? We're going to see that this is a number given, okay? Okay. So free fall acceleration is denoted with the symbols AJ, generally, or G or J on Earth's surface, okay? So these are basically the symbols that we're going to use for free fall acceleration, okay? Remember, this presentation is on the LMS, I think. Si no, yo lo puedo subir. No hay problema con eso. Okay? So, sí. Okay. Okay, vamos a continuar. Okay. So free fall acceleration is the same for all objects regardless of mass. All objects gonna fall at the same time. So it doesn't matter the mass of the object. All the objects have to fall at the same time. Okay, that's very important that we know it. So, for example, this book, El Libro de Ustedes, will use the value of gravity, ¿verdad? 9.81 meters second square. Okay, ese va a ser el valor de la gravedad. Siempre vamos a usar ese mismo valor. Por lo menos, ¿verdad? Cuando hablamos, ¿verdad? En este libro. Puede que otro libro tenga otro valor, pero we're going to use 9.81 meters second square. So that is given, okay? That is given. That's the gravity we're going to use in all our problems, okay? So free fall acceleration on Earth's surface is negative 9.81 meters second square at all points in the object's motion, okay? So that's a unit or a quantity that we're going to use for all problems, okay? Consider a ball thrown up into the air. It's going to have the same gravity, okay? So moving upward, the velocity is decreasing, so acceleration is 9.81. So if we throw a ball to the air, the velocity is decreasing and the acceleration is going to be positive because it's up. So in the top of part of the path, velocity is zero, so acceleration is negative 9.81 meters per second square. Eso cuando está arriba, ¿verdad? Tiramos la bola y cuando está arriba, pues la velocidad va a ser, ¿verdad? Va a ser cero, ¿por qué? Porque se detuvo un momento. Y la aceleración va a ser negativo 9.81. Ahora bien, ¿verdad? Cuando va a caer, velocity is going to increase and the acceleration is going to be positive 9.81 meters second square. Okay? So when the ball is in a position that is not moving, the acceleration is going to be negative 9.81 meters per second square. So when the ball is moving up, it's going to be 9.81, and the velocity is decreasing because it's going up. And when the ball is falling down, okay, or free fall acceleration, velocity is increasing, and the acceleration is going to be the same, 9.81 meters second square. So in all problems, we're going to use the same gravity, okay? ¿Estamos con eso? ¿Cuándo es negativo? Cuando está en un uniforme, o sea, cuando está sin movimiento. When it's not moving, cuando la velocidad es cero, ¿verdad? Cuando está en un punto uniforme. Okay? So when it's going upward, it's going to be positive, and when it's going downward, it's going to be positive also. Okay? Okay. So let's see a problem of how does this work. Okay? We got a sample problem. ¿Alguien quiere leerlo rápido? El problema. Léelo Leonardo, creo que fue. Thank you, Leonardo. So we have a volleyball. So the volleyball is moving with an initial velocity. So we are given the initial velocity of the ball. And it says if the volleyball starts from 2.0 meters above the floor, how long will it be in the air before it strikes the floor, sorry. So we are trying to find the change in time, okay? Estamos buscando el cambio en tiempo, okay? Vamos a ver entonces, okay? We are given the initial velocity is positive 6.0 meters per second, and the acceleration gravity is going to be negative 9.81 meters second square, okay? And we got the change in y, that is negative 2.0 meters, okay? Eso está dado en el ejemplo, okay? Porque dice que it starts from negative 2.0 meters, ¿verdad? Básicamente eso es lo que mide ¿verdad? El jugador. So es negativa porque está, ¿verdad? Eso hay que restarlo a ¿verdad? Al initial velocity, okay? So, ¿verdad? Por eso es que dice negativo 2.0, okay? So we place the origin at the starting point of the ball. Okay, so that's why it's negative 2.0 meters. Okay, and or unknown, the value that we're searching for is the change in time, o cuánto tiempo se tarda la bola en el aire a caer al suelo, ¿verdad? Falling objects. Okay, so that's the question we're trying to answer. Okay, tiene que ponerle mute. Se escucha un revolú por ahí. Dante, ponle mute. No problem. Okay, so the plan we're going to do is choose an equation or situation, okay? Both change in time and ¿verdad? Estamos buscando la velocidad final are unknown. Therefore, first solve for velocity, ¿verdad? Vamos a buscar primero la velocidad final para entonces resolver el tiempo, ¿verdad? First solve for final velocity using the equation that does not require time. Then the equation for final velocity that does involve time can be used to solve for this change in time, sorry. So we're going to start using the formula that we're searching for final velocity, okay? Because then if we have the final velocity, we can see what is the change in time or what is the, ¿verdad? ¿Cuál es el cambio en el tiempo, okay? So we're going to use, okay, so we have to rearrange the equation to isolate the unknown, okay? So the formula that we're going to use is the second equation, okay? Este problema está en su libro, okay? We're going to use the second equation, so it's going to look like this, okay? We got the root square, or the square root of more or less the initial velocity to the square plus 2 times the acceleration times the change in the y, okay? So it's going to look like this. Todo eso lo tenemos, estudiantes. Tenemos la velocidad inicial. We got the acceleration, that is negative 9.8 meters second square. And we got the change in y, that is negative 2.0 meters. ¿Verdad? Que ese es el, ¿verdad? Básicamente, cuánto mide el jugador de voleibol. Entonces, vamos a sustituir los valores. ¿Verdad? This is what we're going to substitute. We got the 6.0 meters per second, que es la velocidad inicial. No sé si están conmigo. The initial velocity is 6.0 meters second square. Okay? And that's going to be added to 2 times the gravity. La gravedad, pues 9.81 negative meters second square. And that's also going to be multiplied by the change in the y, that is negative 2.0 meters. Okay? When we do all this, okay, the first thing we're going to do is 6.0 square. That's going to be 36 meters per second square, todo, ¿verdad? Cuadrado, okay? And we're going to multiply negative 9.1, negative 9.81 times negative 2.0, okay? And we're going to add 2 to all that, okay? If we multiply 9.81 times 2.0, okay, usted va a multiplicar eso y eso te va a dar, ¿verdad? 19.81, and then we're gonna multiply by 2, and that's where the 39 is obtained, okay? Then after that, we're gonna add the 36 meters second square plus 39, and that's gonna be 75 meters per second square, todo al cuadrado, ¿verdad? And when we apply the root square of 75, that's gonna be 8.6, 8.66, and when we, ¿verdad? Eso lo vamos a redondear. We're gonna round the number, and we're gonna obtain that the final velocity is gonna be negative 8.7 meters seconds, ¿verdad? Negative 8.7 meters per second. Okay? So that's gonna be the final velocity. Okay? And it's negative because it's going downwards. Okay? ¿Alguna pregunta de este ejercicio? That's how you're gonna find the final velocity. Okay? After we got the final velocity, that is negative 8.7 meters per second, we're gonna try to find the distance in time, porque esa es la pregunta que te hacía el ejercicio, okay? The question we're gonna answer is how long will it be in the air before it strikes the floor, okay? Now we're gonna see the time, okay? Let's see the other part of the problem, okay? Next, we're gonna use the value of final velocity in the second equation to solve for the change in time, okay? So this is the formula we're gonna use, okay? The change in time is equal to final velocity less the initial velocity divided by the acceleration. So it's gonna be negative 8.7 minus 6.0. That is going to be negative 14.7 meters per second, okay? Porque los dos son negativos, así que va a dar negativo. So básicamente se va a sumar. You're gonna add negative 8.7 plus negative 6.0, that's gonna be 14.7, and then you're gonna divide negative 14.7 meters per second divided by the acceleration. And when you divide negative 14.7 divided by negative 9.81, that's going to be 1.50 seconds, okay? And it's gonna be positive because negative and negative are positive, okay? So that's going to be how long the ball is going to be in the air before it strikes the floor, okay? Any questions on how do we do this, okay? So the ball is going to be in the air, ¿verdad? 1.50 segundos, que viene siendo, ¿verdad? Casi 2 segundos, ¿verdad? Okay? Preguntas de este ejercicio. Okay, that's how basically you're going to do a problem of falling objects, okay? Vamos a continuar. Okay, so the solution is 1.50 seconds. So that's a reasonable amount of time for the ball to be in the air. ¿Verdad? Si usted le da una respuesta bien extraña, por ejemplo, nos hubiera dado 15 segundos, pues eso no sería razonable, ¿verdad? Tiene que ser un tiempo bastante razonable. ¿Okay? Estamos, duda, ¿verdad? Depende de lo que estemos trabajando. ¿Okay? Esto es un voleibol, pues no va a ser un tiempo exagerado. ¿Okay? Pregunta hasta aquí, ¿estamos? ¿Dudas, preguntas? Ok, so ahora voy a dejar de compartir para hacer otro ejercicio.